Hi, nice to see you. It's Hat Thursday.
Hat Thursday.
And it was raining outside. Yeah. So, what we're doing?
Oh, it's Horton.
It's Horton, and Horton, just missing you a lot. I just had to have a picture up just for a minute, just for a second.
Just for a quick one.
But we can get rid of it now. Although I don't really know how to get rid of it. Let's find out.
I need to
Turn your pen on first. There we go.
Okay.
Let's
go back.
Do that. There you go.
Okay, so we're going to start with, this isn't right.
No, that's not right.
We're going to start with simple interest.
Simple interest today.
We're going to start with the simple one.
Yeah.
Simple interest. Okay, so interest is something that is given to you.
Okay.
Because it's a good thing, and you are going to add it on to maybe an investment, some money, something might grow in simple interest in terms of
what, like plants?
Plants, money. Weight.
Okay.
Whatever you want. So simple interest is the easy one. Okay.
Mm-hmm.
Now let's say we start with a certain amount of money.
Yep.
Let's start with £500.
Okay. £500.
And it's going to grow in simple interest of 3%.
Will this grow in a bank?
Yeah.
So we take this money, we give it to a bank, they do stuff with it, and because they borrowed our money, they give us extra money back to pay us for borrowing them, for lending the money.
Yeah.
So this bank is going to give us a 3% interest rate.
Each year.
Each year.
Okay. So simple interest is where you simply work out the 3% and you add on that amount of money for however many years your money is in the bank for.
So should we say 10 years?
Yeah. So let's say we're gonna have it for 10 years.
10 years. These three numbers are the important numbers that we're now going to use.
Yeah. So first of all,
let's
find 3% of 500.
Okay. Well,
so 1%.
Should we do it in our heads, shall we?
1%.
1% is £5.
£5.
Because if I divide it by 100, I'll get 1%.
And therefore 3% would be 3 times that.
£15.
Which is £15. Now that is my interest, okay? And that is the amount that I'm going to get every year.
Every year.
I'm going to get that for 10 years.
Oh, well,
so
that's easy, isn't it?
It's simple.
It's £150 at the end of it.
Therefore, at the end of the 10-year investment, I would have a total of
£150
plus my investment.
Okay.
So I'd have £650 in total.
So be careful when you're answering these questions. Have they asked you to find the interest, or have they asked you to find the total amount at the end of the investment, which is the 500 plus 150? Read the question carefully.
Yeah. Okay, so this next one is just to practice again. We're going to invest £2,000 for 5 years, 3% simple interest. We're going to find the amount of interest, and we are also going to find our total amount at the end of the 10 years.
Okay, lovely.
Okay, so first of all, we're going to find 3% again. So 1%.
£2,000 first of all.
So that's 2,000 divided by 100,
£20.
which is £20. Which means 3%.
3 lots of that
is 60. So my answer to this one would be 60 times by
5
the
years.
amount of years.
6 5 to 30.
Which is
300.
300. And that's my answer.
Lovely.
I'm just gonna highlight that one.
Oh, with a brown colour.
Oh yeah,
nice.
that brownie
Haven't
orange.
used that colour ever, I don't think.
Oh, crazy.
Total amount.
Total amount. So remember, that is.
Started with that. Have to add that on. Easy.
Easy.
Simple.
Okay, it is simple. But what I would say is, hire people, you are so used to doing compound interest all the time that you forget what simple is, and you apply compound interest to it and you get it wrong. Okay, so please make sure that you understand both.
Now this, before you move on, I know that not only Year 11s have been watching this, because I've heard from a number of people that Year 8s also. So I know William B in Year 8, your mum just spoke to me this morning and said you've been watching our videos. This sort of stuff is for everyone.
Yeah.
Every single year group can get something out of this. So if you're watching, think about the fact that when you come back to school, you're going to be doing this stuff. If you've watched this, you're already ahead of the game. Well done.
Lovely. Okay, so Jack invests £2,500 for 10 years at 6% simple interest. Work out the amount of interest. And this one is for you guys at home. Jack receives. And also, how much does Jack have
at the end of the 10 years?
At the end of the 10 years.
Beautiful.
So that is for you guys to have a go at home, and then we're going to see you in a minute. So
I think we'll be freezing.
Have a go.
And we're back.
So I'm going to do the answers in this nice.
I was
going to, lilac-y colour.
Lilac.
Very nice. Okay, so work out the amount of interest Jack receives. So 1% of 2,500.
Okay, so divide by 100, we're saying £25.
£25. How would we do that on our calculator, Mr. Casey?
Well, we shouldn't need to do it on a calculator.
We shouldn't, but let's say a nice, quick and easy way of finding 6%.
Well, I would do 1 divided by 100. Or 6% you want to do straight away?
Yeah.
Okay, 6 divided by 100 times 2,500.
2,500. Or 2,500 times by 0.06. Same thing.
Using the multiplier.
Yeah.
Yeah.
So 6% would be 6 times that, which would be 150. We're going to get that for 10 years. He's really going to be in the money.
It, isn't it? 10
so
times
150 times 10 gives us our answer of £1,500. That is the amount of interest. Let's just recap that.
So that was 1% of 2,500. We times it by 6 to get 6% of 2,500, and then we times that by 10 because we get that for 10 years. That's our total at the end.
Smashed it. How much does Jack have at the end of 10 years? He has his investment
2,500
plus
1,500.
his interest. He is seriously in the money.
£4,000.
Yes, £4,000.
That's why banks don't offer 6% interest, of course.
No, but I do remember when I had a child savings account, I got 5%.
I can't remember that far back when I had a child savings account. I've been a child for so many years.
5% interest.
5% is brilliant.
That was brilliant stuff.
Okay,
paid for my university.
Did it?
Right, yeah.
Wow.
Okay,
that's when university was cheap though.
Yeah, before it tripled. Okay, we're moving on.
Compound interest. Ooh.
Okay.
Now I've put here growth and decay as well because this kind of relates to a lot of things. So you can see questions on decay, the number of trees in a forest are dying out, or population increases, those sorts of things all come under growth and decay. But we're going to start with money because that is generally how they ask the question.
Yeah. So, should we do one example with money and then one example as a population?
Okay, let's do that. I quite like that. Yep.
So, okay, let's do money. Now, it's really important that you nail this formula. Okay. Now, compound interest.
We're going to have different ways of doing this.
Ooh.
So you go ahead first. I'm going to step out.
Okay. So, I use a formula for compound interest. Okay. So I'm going to give you the bare bones of what I'm doing. I'm going to invest £3,000. And I'm going to do that for 7 years. I'm going to get 2% compound interest. Okay, so it's the amount I'm investing times by. Now, because it is an increase, because it is 2% increase, it's what you originally have, which is your 100%,
100% of that, yeah.
plus your 2%, which is 102%. Now, 102% as a decimal is 1.02.
Yep.
Okay, it's your 100% plus your 2%, so it's 1.02, and it's to the power of the number of years. Okay, now this is because as you times it by 1, you then times it by itself again, and times it by itself again, and times it by itself again. That's how. Oh, do you like that? That's why that's what that power does. Because remember, power is just times it by itself. So it's like you're taking your investment for the first year, you're then timesing it by what you've then got after the first year.
Adds the 2% on.
Adds the 2% each time.
Yeah.
So
and
you're
then
always
it takes
building.
It takes that total and times it by 1.2, and then it takes the total and times. So you're doing it every single time.
That's why.
Where with simple interest, you just do it once and then times it by the amount of years.
Yeah. That's why this is actually a better form of interest to gain more money, because it always creates 2% on what you now have each year.
Grows
so
on
if you're
year
going
on
to do
year.
it each year, you would do 3,000 times by 1.02, get your answer, then take your answer and times that by 1.02 again, and you'd have to do that 7 times. You would end up with the same answer as the formula, but obviously that's going to take more time. So the important thing for you guys to take in is this formula, which I'm just going to go over one more time. The amount you're investing times by your decimal, your 2%, which would be 1.02 to the power of 7. And Mr. Cason's just grabbed a calculator.
Grab the calculator, which I'm going to let you have.
Thank you.
Simply because I've lost my glasses and I can't read the calculator without them. Oh, here they are. Fantastic.
And the answer is £3,446. Now, I'm going to round to 2 decimal places. Why would I do that? Because I want pennies, okay? So I've got 0.57 in the calculator, which is 0.06.
Okay, so I mean, obviously I do it in exactly the same way. I thought you were going to do some mnemonic in order to remember what to do. So when I teach this, I always teach turn. Turn, yeah? So T, the total, I'm going to write it here just for a minute and then rub it out. T, which is my total, equals the initial times the rate to the power of the number of years.
Oh, very nice.
Yeah? So I always teach turn. I used to teach this, total equals initial times the rate to the power of the time.
Turt.
But turt sounds a bit rude. I don't know.
Sounds kind of like turd.
Yeah, so I didn't like it. So I tend to teach turn.
Yeah, I like it.
Turn.
When I just say it.
Well, yeah.
But yeah, I like it. So we've got total. Ooh.
Yep.
We've got total times by.
No. Total equals equals initial times rate to the power of.
I've got you.
Number of years. Yeah.
I'll go again.
So total is over there.
The total equals the initial times by the rate. Your rate is your rate of interest to the number of years. Turn. I like it.
Okay.
I do really like that.
Okay.
And I always think, how will I get them to remember it? And that is a really, really nice
one. It's a turn. We're going to have a turn.
So we're going to do some growth now.
Okay.
So we're going to have a population of 300,000 people, and they're going to grow. Their population is going to grow by, what would be a good population growth?
Well, I think probably by about 4% per year.
Well, I was going to say
4%. Make mine think alike. 4%.
4%. Yeah. And I want to know how much my population is going to be after 5 years.
So 300,000 people, 4% increase per year, compound for 5 years.
So it's going to be the same. It's going to be our total is going to be our initial times by our rate and the number of years.
Okay,
so our total is going to be
initial 300,000
initial times by our 1.04.
Because they're not all going to disappear. They're all going to be there having babies. So every year you're going to add
100% plus your 4%, and it's going to be 5. How many people do you think we're going to have?
Oh, I reckon 321,000.
Oh.
Do you want a different calculator?
No, it's okay. No. It just needed a good whack.
Okay. What is it?
364,995. Now it says this. We're people.
Yep.
But should we still round to the nearest whole number? Should we round up or should we round down? Controversial statement.
Okay, well the exam boards seem to have 2 views on this. If you say you can't have 0.8 of a person, you can round down.
Yeah.
If you believe that this 0.8 is so close to another person that who
Might
cares,
assume it is.
you can round up. Both answers seem to be correct.
Oh, I like it.
Both answers. As long as you must not leave the decimal. Do not leave the decimal. Either round up or round down. Personally, I would do what you've just done and say you can't have 0.8.
Because that could be a baby at like 6 months in a month's time.
Could be.
And it's not quite ready to go.
It could be. Yeah.
There you go. There's a nice little thinking there. So we're going to move on to an example involving money. We're going to invest £500 in Bark West Bank for 7 years at 3% compound interest. So let's do our formula. We're going to have our total times equals our initial times by our rate to the number of years. Okay. You've really changed blown my mind on that. I love that we're all learning.
It's because I'm quite simple. I need simple ways of remembering things.
So we've got 1.03 because we've got our 100% plus our 3%.
Number
of years
7.
7 years. Let's see how much we've got.
Let the calculator do the work.
which is brilliant with these ones because this is going to be in a calculator paper, and we're going to show you some more complicated versions next, and therefore you need to be super quick with this bit because you'll have more to do.
Yeah, good.
And there's our amount,
£614.
which is beautiful. Does anyone have any questions? If you do have any questions, do
Just
email us.
Email us, please do.
Okay, this one is for you. So we'll leave this one for you.
I'm going to grab the tea.
I might have a little sip of water.
Okay. I'm back.
I'm coming.
She's gone. Do you want me to write this one? Tea?
Yeah, go for it.
I'm going to do the tea.
Joe's going for it.
R-N. Okay. So our total equals our initial, so £1,000.
£1,000.
Times our rate, which is 2.5.
So 100 plus 2.5 would just be 102.5, which is 1.025. There's only one place that 5 can go after the 2. Think to yourself, 2% would be 1.02. So 2.5% is 1.025.
We put this in because this is a common little twist from the exam board to catch you out. And 8 years.
8 years. 1,000 times by 1.025 to the power of 8 gives me £1,218.40. Beautiful. Like it?
Lovely.
Oh. Okay, comparative, okay? Now, this is also incredibly common, okay? They like to compare, okay? And they like to give you two different things. I always say to my guys, make it nice and obvious for your examiner and give yourself a bit of a table.
Yeah.
Just because you're saying to your examiner, I'm going to organise my work, I know what I'm doing. Yeah, I've got this on this side, I've got that on that side. You don't have to search for my answer is right here. So, we've got simple, be careful, read the question. Simple interest here, compound interest here. Now, we don't have an amount to invest in our banks.
So what we're probably saying is it doesn't matter how much we invest. One is always going to be a better deal than the other. So we could just make up an amount.
100.
100, nice, easy number.
100. So, £100 is what we're investing. So let's make sure we know that. Okay. So I need to find 1.75% of £100. Well, that is just going to be £1.75.
Yeah.
I love how to really think about that.
Think about that.
£1.75. I'm getting for 4 years. It is. 1.75 times 4. Yes, only £7. So in total, I'm going to have £107 at the end. That's my total.
Okay. So over here, we want to be T equals I R N. So our total is going to be our initial, which was our 100, times our rate, which is 1. Okay, so we want 1.0165.
Always say to my guys, think about what it would be as 1%, then just add on the rest.
Add on your decimals. And that's for 4 years?
Yep.
Okay,
so
could you
got
work that out,
100 times 5, 1.0165 to the power of 4. And we get, it's very close, but it is always seems to be better. Floyd's is better.
Floyd's is better. And
so show that Floyd's is better. Circle it. Better. Beautiful.
Excellent.
I love that one.
Excellent.
I keep trying to play with the numbers to get this one to be better. But
well, with another year probably would have done it.
Yeah, it's not the amount of years. I always want to try and work the percentages so that one ends up better. Because compound
generally is
better, but yeah. Okay, this is another thing that they do. Okay, so he's a bit tricksy.
Yeah.
Now a lot of people do this. Okay, a lot of people I know do this.
You don't do this because you haven't got any money.
I don't do this because I can't be bothered. But you get a lot of premiums when you skip from bank to bank. Okay, when you invest your money in the bank for a first year, you get this kind of really good interest. They'll say, "Oh, come to us and we'll give you 3% for the first year." Yep. And then you leave that bank and you go find another bank that's going to offer you the same thing.
Absolutely.
Okay. So
Mr. Cheeseman's got a lot of friends who are in the banking sector.
Very savvy with their money. So Jack invests £2,000 for 2 years at 4% simple interest.
So
He
we-
then moves his money.
Okay, so we need to kind of work that out first, I think.
Yeah,
And
let's circle
then
our
moves it,
important
yeah.
information. So
Okay.
this is our initial.
Yeah,
Then we're moving over here
yeah.
to our 4%.
And can we have the 2 years?
Oh
as well?
yeah, we need the 2 years as well, absolutely. And then he's going to move his money, and he's going to move his money at a rate of 3.75
And it's going to be for 10 years.
for 10 years. Okay, that's our initial information, but now we need to work through it. So let's start with our first 2 years.
Go for it.
So £2,000,
Mm-hmm.
and he's getting 4%.
So
1%
is 20.
is 20. So 4% is 80.
£80.
And he's getting that for 2 years. So I'm going to double it.
£160 in total.
So now, after those 2 years, he has £2,160.
Which, in a way, is our start point
It's our new initial.
for this stuff.
Yeah.
For the compound.
Because he's now going to take that money. He's not going to start again with the 2,000. He wants to make as much money as possible. So he's going to take that money and he's going to move it into the new bank because he wants to make his money, and you can make a lot of money through doing this.
Initial?
So £2,160
Rate?
times by 1.03. If it's 3%, that's where I end. I've got 7 and a 5.
Power of 10. 10 years.
10 years. He's going for the big money.
Give you a little bit more space.
Oh. And you get £3,121.29. And just check back. So Mr. Casey mentioned this at the start. Check back on your question. Are you done? What did the question say?
It said,
how much profit does he make in his investment? Is this profit? No.
No.
This is total. Okay? So look, we've even named it as T. He had £2,000 to begin with, so we need to find the profit now. Let's extend that page. So if I take away my initial, I will find my profit, which is 121. No,
no.
1121.29.
Beautiful.
And that is now my profit. Okay? Always check back on your question. I say this to my people all the time.
Reread it.
Have you answered the question? You've done all of this work. It might be lovely and beautiful, but you might be 1 mark away from getting that final mark.
And this would get you 3 out of 4. 4 out of 4.
Love that. Right, moving on.
Oh, decay, depreciation. So things don't always get better or increase, sometimes they decrease, and this is where we're going to use compound interest in order to show you some decay. So I've put bees dying at a rate of 6% per year. There are 70,000 in a hive, which is about right. In 2020, how many are left in 2030?
So, here we're not having our 100% plus 6%, here we're having our 100% minus 6%, okay? So you've got to think about what that multiplier will be. If it's 100% minus 6%, you're left with
94%.
94%.
Okay, so
our
total equals our initial
70,000
70,000
times by our rate. Now we are timesing by the 0.94, okay, because we are decreasing, we are minusing the 6%.
And that is the important bit. This is the bit that everyone then gets wrong because they think it's going to be 1.06, but that would be a 6% increase.
Yeah.
So this is going below 100%, 94%, and that's how we write 94%. Number of years?
10. Because we're going from 2020 to 2030. It hasn't said 10 years in the question, but it has assumed it.
Yep.
I need to just whack out that
the calculator. Here we go.
So we had 70,000 bees
times
0.94 to the power of 10. We've only got 37,703 bees left. That's really sad.
That's sad.
The bees have halved, basically.
They have, haven't they?
Oh, that's so sad.
Let's
and this
on.
is this is actually happening.
This is happening. Bees,
so
yeah.
Save the bees.
Save the bees.
Right. Okay. Next one.
Oh.
The half-life of Knoleium.
I saw a question like this many years ago because obviously I've been teaching since 1920, and I saw this question many years ago, or a question very similar, where they talked about half-lives and things. Now the half-life of a radioactive chemical is about the number of atoms reducing to half of their initial rate. So we're talking about 50% decrease.
50% decrease.
Okay.
So a 50% decrease, 100% minus 50% is just 50%. So that's nice and easy.
Going to use the same process.
Yeah.
I nearly forgot it then.
Total.
Total's what we're looking for.
Initial
Is this thing here?
is a
This
very
is
big number.
standard form.
And you can put that in your calculator, or you could convert it. I mean, it's completely up to you. If you're going to put it in your calculator, I would suggest whacking it in a bracket. Times by 0.5 to the power of...
Well, I've got 30 years there.
30 years.
30 years.
Now, you could convert this number if you wanted to.
Could.
You don't have to.
When I actually wrote this, I thought I was going to write 30, but I kind of forgot the 0, so let's leave it as 3.
So I'm going to prove to you that you can do it. I'm going to write it exactly like it is on there, and I do not tend to use
standard
button.
Can you show that to the camera once
I
you've
will.
typed it in? That'd be good.
I think that would.
I like your riding hat, by the way.
I really like it.
It's good,
I'm going to take
You're
it with
take it home.
So,
Here we go.
let me just see if you can.
Can you see that?
Oh yeah, you can
Can
see
you see
it.
that?
Brilliant.
Yeah, that's how we've typed it in.
That's how it needs to be, guys.
So
don't trip and fall.
Don't trip over.
Oh, okay. It's like a really small number.
Oh, right. There's not much left, basically.
2.42. I'm going to round it to 3 significant figures. Times 10 to the power of minus 6.
Oh, that's not really an atom then, is it?
It's basically a nothing.
It went to nothing.
Oh, that's sad.
Stick 30 in there, see what happens.
Okay.
Okay, I'm just going to put 30
Remember,
there.
you can just click through.
And let's see if we get a better answer.
Yeah.
Is that better?
Yeah. 2.42. Of course, it's going to stay the same. Times 10 to the power of 21.
That's better, isn't it? That's a more realistic answer.
Okay, it's reduced.
Yeah.
Lovely. Okay. So just remember, when you're looking at this half-life, just think 50%.
50% each year, drops by 50% each year. What
And
else
I
have
like
we
this
got?
because they always do these crazy things. There is one more that I want to do.
Oh, there's always one more.
2 more if I'm going to be really specific.
Two more. Okay,
so
do them.
these questions come
I'm gonna
up.
get the tea and watch it.
Okay, these questions come up, and what they do is they are not looking for your total. Okay, they give you the total, and they give you the percentage, and they give you the outcome. Okay, and they ask you to find the number of years.
Oh yeah.
So, and that's the one I'm going to do, and then I'm going to do another one where you have to find the percentage. So, this first one is foundation. Okay.
Yep.
So, we are going to invest £3,000, 5% compound interest.
Yep.
Okay, and I'm going to get out. Pause for effect.
Pause for effect.
You can watch Mr. Cason drink his tea.
Pretty boring.
And you get out. At the end of the
period of 5
period
years.
of time.
No, there is no
period of time.
There is no time.
You get.
So you've worked it out by putting the time in, but we don't know what time.
You don't know what it is.
Okay.
So this is the amount. This is the percentage. Okay, and you have to find the period of time. It will say to you, how many years did you invest your money for to get 4,432? Now, if we use this,
we'll have something missing, won't we?
We've got our total.
Got the total 443237.
We've got our initial. We've even got
1.05.
But we don't have that. Now, the only way to actually solve this is to use something called logarithms, which are A-level, that's not you.
We're not going to do that yet.
And so, therefore, the only way you can do this is through trial and error.
Trial and improvement.
Trial and improvement.
Trial and error, that's
old school.
Old school.
So, if we're doing it for trial and improvement, we're going to put in our amount into our calculator with our percentage, and we're going to just go, okay, I'm going to go for... 4? I was going to go for 5.
5? Okay, try 5.
I'm going to try and put in 5.
Oh, write the answer down.
And the answer is 3828.84.
That's not enough.
It's not enough, so I'm going to jump up to 7.
7 years?
And Mr. Massey came into our room the other day and he was like, oh, do you need to write it out every single time?
Yes, you do.
Yes, you do, Mr. Massey, you lazy person.
Yeah.
So, because that's how you get your marks, people. 422. 1.30. Now we are very close.
We're very close. I'll go up one more year.
Let's go one more.
1.05 times 10 to the 8.
Now, Hermione, who's in year 10, she said to me, what if you get it right first time? Could happen. So if you do get it right first time, just do it another year and write that down, and then you've got a bit more work.
Just to show you.
4432.37. Therefore, my conclusion would be 8
years.
Years.
Would you need to write the 8 years? I think you would, wouldn't you?
Oh, 100%.
You don't want to leave that because the examiner might not see it properly because some of them are blind. So 8 years.
8 years, make it obvious, make it clear.
Yeah.
Okay, so that is your foundation sort of missing information question.
Lovely.
This next one is your hire.
Hire, put a big H.
Okay,
Lovely.
so here we have the amount we're investing, and we also have the number of years, and we also get out. We also have how much
It'd
we
be good
have.
if we prepared this one, wouldn't it?
It would have been,
Yeah.
but you know what?
It's
Pause
nice
for-
sometimes.
Pause for suspense, and also
Yeah.
we're all human. So 4,082.
Handbags.
4,082.59 is the
Yeah.
amount I'm going to get after 7 years.
Okay.
My
what's
question
missing?
is,
What's missing?
what
Ooh.
interest?
Interest rates missing. We've got the number of years.
What?
We've got
The interest. Oh, good guess.
What's the interest? What interest? Yeah.
Boom. What's the interest?
What is the interest? Okay.
What?
So can I write TIR just to sort of
Yeah,
TIR?
always. Set up your equation.
Beautiful. Okay.
We've got our total.
We have. It's 4082.59.
We've got our
7,000.
initial. We do not have
Oh.
our interest. And we do have our
7.
number of years.
Yep.
Now, we're going to have to solve this, and it's all lovely and beautiful.
Good.
And we're going to do it by using balancing method or opposite operations, whatever is your jazz. So I'm going to first of all divide
Both
by
sides by 3,000.
3,000.
Oh,
So,
interested to know what that is?
answer divided by 3,000 gives me 1.36086,183. Now, do not round mid question, very, very important.
Do not ever.
Left on this side is x to the power of 7. Now, to reverse said to the power of 7,
root 7.
we need to root 7 both sides. And you can do that on your calculator, no problem.
Because you've got that still in your calculator because you haven't cleared it, have you?
Yeah, no, I haven't.
No, of course not.
So I'm going to do root 7 to the answer, and I'm going to get 1.045.
Ooh.
Now,
Oh.
is that my answer? No.
Well, no, it's not because the question said, if I remember rightly,
What's the
what's
interest?
the interest?
Therefore, the interest
Is the rate
is
of
my
interest.
100% plus here,
4.5.
which is 4.5% as my conclusion. Now, what they do here is because they give you a rounded number, quite often you have to round this, okay? So it would tell you what to round, and what you could have had here was 4.9999888, and you needed to round it.
5%.
That's the tricky bit, but you would only lose 1 mark.
Beautiful.
It's about solving it.
It is.
That is it for today.
It is.
And just check out Show My Homework for all those lovely tasks that I've put on.
Yeah.
See you later.
See you later. Bye.